Very good morning to all of you. Once again, I welcome all of you in today's practical. So, up till now, we was covered 8 practicals. Okay. So, almost all the practicals we were completed throughout this particular semester. So, in the today's practical, we are going to see, as per your syllabus, how to plot the graph for different practicals. Okay. So, as far as concerned with your Batu syllabus, so whatever may be the result you got at the end of each practical, so we have to plot the graphs with the help of Excel sheet. Okay. So in the today's practical, we are going to learn how to plot the graph with respect to the Excel sheet. Okay. So we are going to learn this aspect in today's practical. So I am going to share the today's presentation content. Now slide is visible.
Yes.
Okay. So under group A and under group B, we have completed this 8 practical. Okay. So as far as concerned with the first practical under group A, calibration of V notch or rectangular notch, then determination of or the calibration of ogivir, then study of hydraulic jump, then verification of sequence depth in case of the hydraulic jump, loss of energy due to the formation of hydraulic jump. Then we were calculated the Froude's number, the depth ratio y2 by y1, and then also we were calculated the length of hydraulic jump, then energy loss due to the formation of jump, then study of flow below gate, then velocity distribution in open channel in transverse direction of flow, then group B, impact of jet, study of turbines. We have 3 types of the turbines: Pelton wheel turbine, Kaplan turbine, and Francis turbine. So we were determine the efficiency of turbines, then test on centrifugal pump, then selection of chart for the pumps. So these are the practicals we were completed under this hydraulic engineering laboratory. Now if you see here, one note will be given for the as far as concerned with the graph. So use of computer programs such as MS Excel is desirable for post processing of result. So whatever may be the result you have got from each and every practical, so what we have to do, we have to create a graph with the help of Excel sheet. Okay. So in today's practical we are going to learn how to plot the graph with the help of Excel sheet. So I am going to share the Excel sheet. So what you have to do, you have to create a new Excel sheet. Okay. So after creating the new Excel sheet, you have to open. For example, you have to rename it also. Rename the Excel sheet. Not responding. Okay, so the first practical, if you see here, how to plot the graph. For example, calibration of V notch or rectangular notch. Okay, so the aim of the practical is calibration of V notch or rectangular notch. So first you have to uh, format the page. So we have to keep the row height. So you have to keep row height 30. Okay, then we have to write the aim of the practical. Okay, so aim of the practical, calibration of V notch. Okay, calibration of V notch, that is triangular notch. Okay, that is triangular notch. V notch means triangular notch. Okay, then increase the font as well, keep as a 16, and then fill the with one color if you want to fill the color. So this is the aim of the practical, calibration of V notch, that is triangular notch. Calibration means we have to determine the coefficient of discharge. Okay, now we have the observation table. Okay, so we have to plot the observation table. So write down observation table. Okay, we have to write down the observation table, increase the font of the observation table, then we have to write the all the columns in observation table. So serial number. Okay, the second column for the calibration of V notch is head above the crest level. Okay, head above the crest level, head above crest level or seal level. Okay, or seal level, that is H in meter, H in meter. So wrap the test and do the center. Okay, so here you also increase the font as well. So the head above the crest or seal level. Then next column is rise of water level in measuring tank. Okay, rise of water level in measuring tank. that is, now here we have the head above the crest level is capital H, okay, remember. And in case of the rise of water level in measuring tank, that is small h in meter, okay. Wrap the text and do the center. Then the next column will be time taken to rise water level in measuring tank, okay. So here we have the time taken to rise, time taken to rise water level in measuring tank, that is T, okay, that is T in second, okay. In place of this we have to write second, okay. So next column is we have to calculate actual discharge, actual discharge, that is Q actual, okay, in meter cube per second, in meter cube per second. Wrap the text, okay. The next column is now theoretical discharge, the next column is theoretical discharge, and last column is this column is theoretical discharge, theoretical discharge, that is Q theoretical, okay, Q theoretical, and last column is coefficient of discharge, coefficient of discharge, coefficient of discharge, that is CD, okay. Wrap the text, do the centering. So this is the our observation table, okay, this is the observation table. Now look at the observation table. What you have to do? You have to do the all border, then bold the first row, okay. Now serial number 1, 2, 3 and 4, okay. We have the serial number 1, 2, 3, 4. Now if you see here how to take the this particular head above the crest level, I will show you. So this is a complete observation table. Okay. Now that is the aim of the practical is, okay, the aim of the practical is the aim of the practical is calibration of V notch. Okay, calibration of V notch, or you can say a rectangular not triangular notch. Okay, not a rectangular, this is triangular notch. Okay, now if you see the diagram for triangular notch, the triangular notch is like this. Okay, this is the ground level, and this is the depth of water in the triangular notch. Okay, this is the depth of water D. Now we have the angle theta. Theta is given in the manual which I have post on your group, that is 60 degree. Okay, the angle of the V notch is given 60 degree. Now this D, or this is called as H. This is also called as H. Head above the sea level. Okay, D or H. Now here we have the sea level. This is your sea level or crest level. Okay, this is also known as sea level. So whenever the water is coming from the dam and we have a position across the channel, for example, this is a channel. Okay, this is a rectangular channel. This is a channel. This is longitudinal section, and the water is coming from the dam by opening the gate, and here we have the position of V notch. We have fixed the notch at this position. The water is coming at this particular V notch and flowing over the sea level of the notch and having a head above the sea level. Okay, head above the sea level. So if you see the manual which I have posted on your, you can see the group. So I am going to open that manual. Slow, net is slow. Okay, so I am going to open that manual. From your group. So this is the, you can see the complete our observation table, serial number, head above the sea level, rise of water level in measuring tank, then time taken to rise the water level in measuring tank T, actual discharge, then theoretical discharge, and then coefficient of discharge. Okay. So So what is the head? Now here we have the head above the sea level, okay, and I have mentioned in the manual as well. So I am going to open the manual which I have posted on your group. So for example, the head is 38, okay, the head is now 38 centimeter. For example, the head is 38 centimeter, that is 0.38 meter, okay, 0.38 meter. So for the first reading is the head is 0.38 meter. Now we have a notch, okay, we have a if I show you the triangular notch, now see here, uh, this is, we called it as a triangular notch, okay, this is a triangular notch which is fixed to the channel, okay. Now this is the sea level, you can see here, this is a sea level, and above this sea level we have a head. Means if you open the gate from the dam, the water is coming on the upstream side and it is flowing over the sea level for a certain height, okay. Now here we have a channel and we have a V notch and we have to measure the head above the sea level, okay, head above the sea level, okay. So this is the head above the sea level. Now if you see here, at the, okay, at the end of this notch we have a measuring tank, okay. Now see here, we have a measuring tank and we have to record the time taken to rise the water level in this measuring tank, okay. So the time taken to rise the water level in measuring tank, so here for example we have a measuring tank at the end of this is a measuring tank, and when the water is coming from the sea level of this notch and coming into the measuring tank, this is empty. So we have to assume this h 0.2 meter, and we have to record how much time it will take to rise the water level in this measuring tank with respect to this height. So and we have to record that here in the observation table. So the rise of water level is 0.20 and this 0.20 is constant throughout the for all the heads. Now the time taken to rise the water level in measuring tank. So for the first reading, what we need to do, we need to open, for example here we have a gate, okay, this is a gate, For the first trial, we have to open 1/4 gate. Okay, we have to open 1/4 gate. So you will be get H above the sea level. Okay. So the time taken to rise the water level in measuring tank for the first reading, for example, 42 seconds. Now we have to calculate the actual discharge, theoretical discharge, and then coefficient of discharge. So how will you calculate this actual discharge, theoretical discharge? I will tell you. The first one is we have to calculate actual discharge. Okay, we have to calculate actual discharge, that is Q actual. So how will you calculate Q actual? L into B into H divided by time, volume of measuring tank divided by time. So length of the measuring tank LB is constant, 3 meter by 3 meter. Okay. So 3 meter by 3 meter by this rise of water level H. This is rise of water level H is 0.2 divided by time. So time is now how much? Time is 42 second, not a 38, 42 second. Now you have to calculate actual discharge. So how much is the actual discharge for this case? Calculate. Yes. How much is the actual discharge? 3 by 3 by 0.2 divided by 42.
0.042. 0.042 meter.
0.042. Okay. 0.042 meter cube per second. Okay. 0.042 meter cube per second. And if you want to generate the formula to calculate the actual discharge, what we need to do? We need to add the one column here. Okay, insert one column again, that is the area of tank, area of measuring tank. One column you have to add, area of measuring tank, that is L into B. Okay, in meter square, in meter square, L into B. Okay, L into B meter square. Okay, and area is denoted by a letter capital A. Take a inverted comma and separate it. So this is the area of measuring tank. So how much area we will get? This is equal to 3 by 3, 3 into 3. Okay, length and breadth is 3. So the area is constant throughout the reading. Now if you want to measure the actual discharge and generate the formula, what you need to do? You need to press equal to arrow with your keyboard. So equal to, then volume of measuring tank divided by time. We have the formula LBH divided by T. So what you need to do? You need to you need to uh, press this area into this rise of water level H, okay, divided by time is 42, okay, then press enter, that is equal to. So this is the discharge. Okay, this is the discharge, that is 0.0429. So you will be get automatically by generating the formula. Then we need to calculate the theoretical discharge. Okay, we need to calculate the theoretical discharge. So in case of the triangular notch, the second calculation is theoretical discharge. So theoretical discharge, Q theoretical, which is equal to, we know the formula, 8 by 15 CD into tan theta by 2 into root 2g into h raised to 5 by 2. So this is the formula to calculate the theoretical discharge. But we have to find out the CD, so we don't take the CD here. So the formula become 8 by 15 into tan theta by 2 into root 2g into h raised to 5 by 2. So this is the original formula, but for the practical purpose we have to take this formula because we have to calculate CD. So substitute the value 8 by 15 into tan theta, theta is now 60 degree, divided by 2 into root 2g, 2 into 9.81 into h. How much h we have taken? 38, that is 0.38 raised to 5 by 2. Okay, now calculate the theoretical discharge. So how much is the theoretical discharge? How much is the theoretical discharge? Yes, calculate the theoretical discharge 8 by 15 into tan theta by 2 into root 2 into 9.81 into 0.38 raised to 5 by 2. Yes, how much is the theoretical discharge? Calculate immediately. I request all the students. Yes.
0.533.
0.533 meter cube per second. Okay. 0.533. सगळ्यांनी चेक केलं का? सगळे किती आहे?
0.121 येते सर.
Yes, 0.121.
हां, किती येतं?
0.121.
0.121.
0.121.
Okay. So the answer is 0.121. 121. Okay, meter cube per second. So here 0.121. Okay, now we have to calculate coefficient of discharge. Okay, so the third calculation is coefficient of discharge. The third calculation is for coefficient of discharge, that is CD. We need to calculate CD. So CD is the ratio of actual discharge to theoretical discharge. Okay, actual discharge to theoretical discharge. So actual discharge we have calculated 0.042. Okay, so 0.042 divided by theoretical discharge is 0.121. So how much is the CD?
3.47 into 10 raised to power minus 4.
Hmm.
Sir, 0.35.
0.34.
Yes, sir.
0.34.
0.34. Yes.
Okay, 0.34. 0.34 is the CD. Now let us check by creating the formula. What you need to do? Press equal arrow on the keyboard. Then actual discharge we have calculated. So press for the actual discharge. Then divided by simply theoretical discharge. Press the value of theoretical discharge and enter it. So here we have the value of CD for the 0.35. Okay. So actually 0.35 because we have taken here 3 digit. So 0.35 is the coefficient of discharge. Now for the second reading, what we need to do for the second reading? In case of the first reading, what we were done, we were open, this is a gate, dam gate. Okay, this is a dam gate. Okay, so we have opened the dam gate 1/4. So the discharge is now less. Now we have to open half wall now. So the discharge is now increases as compared to the previous. So here the reading, that is the head above the sea level, will increase because we have increased the discharge. Okay, 1 minute. So this is how we were calculated. So here we have the head above the crest level or the sea level. Then ultimately if you open the half gate, so you will be get the discharge more. So for time also, in case of the measuring tank, will take less time with respect to this rise. So here we have the head above the sea level. For example, the head above the sea level will increases now. For example, 0.43. As the head will increase, the discharge will absolutely increase, and the time taken to rise in the water level in the measuring tank will decrease for this particular rise. So time is now, for example, 37 seconds. Okay. Now we have to calculate the actual discharge. So volume of measuring tank divided by time. So press equal sign on the keyboard, then area of the measuring tank into the rise of water level divided by the time, okay, and press. So this is the actual discharge, okay. Then we need to calculate the theoretical. So by generating the formula we can calculate, but as the time constraint, here what you need to do, 8 by 15 calculate manually. So 8 by 15 Q theoretical for second reading, so second theoretical discharge, okay. 8 by 15 into tan theta. Now here theta is 60 by 2 into root 2g into h raised to, how much is our h? H is okay, h is 0.43, okay, head above the sea level. So 0.3 is the h. Five by 2. Now calculate theoretical discharge. How much is the theoretical discharge? How much is the theoretical discharge? Yes. किती आला theoretical discharge? शिवम झोरे.
Yes, सॉल्व करते 2 मिनटं.
हाँ. 8 by 15 tan theta by 2 60 by 2 into root 2 into 9.81 into 0.43 raised to 5 by 2.
Zero point 165, sir.
Yes,
0.165.
0.165.
0.165, okay, meter cube per second. 0.165. Now once we have this coefficient of discharge, if you drag down this answer, you will be get automatically the CD. See here, if you drag this one, you will be get. Now here what we need to do, again we need to increase the discharge, okay, full wall position. So here we have, for example, the head is 0.46 and the time taken is now minimum because the head is increases, so the discharge will also increases and you will be get the less time to fill the tank for the point to rise. So 32 second and we have to calculate the actual discharge. So what we need to do, we need to drag this one, so you will be get automatically the discharge. The only thing is that we need to calculate theoretical discharge. So the theoretical discharge is for the third reading, theoretical discharge 8 by 15 tan theta by 2, that is 60 by 2 into root 2 into 9.81 into point, how much is the head? We have taken 0.46. Okay, so calculate theoretical discharge.
0.195.
0.195 meter cube per second. Okay, 0.195. So 0.195 and drag this, so we will be get same CD. Okay, and if again if you increase the discharge, for example, the head is now 0.49 and the time taken to rise the water level in measuring tank is 20 seconds. If you drag this one, you will be get the actual discharge. And simultaneously, what we need to do, we need to calculate the theoretical discharge. So here for the 6 theoretical discharge, 8 by 15 into tan 60 degree by 2 into root 2g into h raised to 0.49 raised to 5 by 2. So calculate theoretical discharge. Okay, now what should be the theoretical discharge?
0.229.
0.229
Meter cube
meter
per
cube
second.
per second. Okay, 0.229. 0.229. If you drag this, you will be get automatically the CD. Now this is the complete observation table we have. Okay, now after this, what we need to do? We need to obtain the graph between head versus actual discharge. Okay, head versus actual discharge, head versus theoretical discharge, then actual discharge versus CD, theoretical discharge versus CD. So what we need to do? Insert, go to the insert tab, then we have a line, 2D line, then select this line, first one. So take below the observation table, then press over that line diagram, line graph, then select the data, then add data. The series name is now head versus head, that is capital H versus head versus actual discharge, that is Q actual. Okay, Q actual. So that is the series name, head versus actual discharge. Then take the series value. So we have the head on x axis and discharge on the y axis. So select this value. Okay, so this is the and take discharge on the y axis and press OK. Now head on the y axis, but you need to take head on the x axis and discharge on the y axis. So what you need to do, again go to the selection section, add data, then series name is H versus Q actual. Now take the value first, this actual discharge, okay, then press OK, and then take this head now on x axis, okay. So look at the graph now. This is the graph we have plotted, okay. Now what you have to do, you have to give the name for the axis title. So go to the layout section. So here we have the one tab, name axis title. So primary horizontal axis, so title below the axis. So we have a title below the axis, and write down this head, okay, head above sea level, okay, head above sea level, head is capital H, okay, head above sea level. Then again go to the axis, vertical axis, rotated title, and give the name, that is actual discharge, okay, Q actual in meter cube per, in meter cube, that is your Q actual in meter cube per second, okay. So this is the method by which we can do the, or we can plot the graph, okay. You can adjust the things. You can change the colors also, you can format all border color or some things. If you want to do the 3D, so you can do the lot of things with respect to this chart, okay. So if you change the color of the particular graph, you can change from here, okay. So this is a complete methods to plot a graph for each and every practical. So this is the first graph, that is the head versus actual discharge, okay, head versus actual discharge. So we have a head, we have actual discharge. Now if you want to uh, plot the graph in between the head versus theoretical discharge and the, let us see here, insert, go to the line diagram, line graph, then go to the selection section, add the data. The series name is now the actual discharge or Q actual, okay, Q actual in meter cube per second versus CD versus CD, coefficient of discharge, okay. Don't write the unit, only Q actual versus CD. Now on y-axis you have to take CD. So drag the CD value. Okay, and on x-axis we need to take actual value on the x-axis, and then OK, click OK. Now this is the graph we have plotted in between the actual versus CD value. Okay, on x-axis we have the actual discharge, on y-axis the value for CD. So this is the graph we have generated. Now if you want to give the series title, or you can see the axis title, go to the layout section. We have a axis primarily horizontal below the, so this is a Q actual meter cube per second, and for the vertical axis, okay, for the vertical axis rotated title. Now we can name that is CD, okay, that is coefficient of discharge, that is CD, okay, coefficient of discharge, that is the value for CD. So this is the first graph we have plotted in between the head versus actual discharge, and then second graph we have plotted actual discharge versus CD. Okay. So what is the use of this particular graph? This graph which is used on the site as well. Once you look on the graph, you can tell for example here we have data. Okay. Now for 49 meter head, we will get how much discharge? 0.0643 meter cube per second. And simultaneously, if you read this another table, another graph we have. So if the actual discharge is now 0.0429, the CD is 0.35. As the discharge is increases, the value for CD is decreases. So you can comment like this, and this graph will be used for the construction of channel. Okay, while the channel will constructed, so such kind of graph will be used by the engineers. Okay, so this is how we can generate the graph. Okay, now today we will stop here. If anybody is having any question right now, you may ask. Yes, Shivam, Kavita, Vanarse, Tejaswini.
No, sir, not.
आणि एक 1 minute, I will discuss